I think the size of comic sense.
Alright, today literal and simultaneous equations. Literal equations are just equations with letters in them. So let's have a look at some examples. Solve for x.
I'm beginning to get my wrong tape to put in. Is this mostly just examples?
Just some examples, 4 examples all up.
Feels gross.
Is this 4H?
Yep.
Because I don't know what to make my something. Like, do I make it a big thing or do I make it a big thing?
Alright, so literal equations is what we call a literal equation just because it's got our normal variable that we would expect for x. It's also got another letter in there, in this case an a. So we follow the same processes, so factorising, and when you look at that you'll notice that there is a common factor. So x squared minus 3ax plus 2a squared. And then we would need to factorise what's inside that bracket. Any ideas?
Oh, gosh, next. An A, X. There's a second X.
I'm going to take that one.
And plus
Yep.
the other one. Not plus it, take
It's
it.
going to be take as well.
You're going to need to put some numbers in.
We're going to need to put some numbers in. We've got to get a 2 somewhere
Yeah.
And a 1.
and a 1.
Oh.
1a.
Where's the three?
Alright, so
Oh, no.
solutions then, x could be 0, x minus 2a could be 0, or x minus a could be 0. So adding 2a and adding a, they're our 3 solutions. Alright, and 2 of the solutions have an a in it. So that's all a literal equation is. Alright, let's have a look at
Oh, is that the answer?
that's the answer.
Oh.
Solve for x,
Oh, yeah.
so we're solved. Alright,
Big solve.
so again we're going to solve for x, so ax cubed minus b equals c. It's a literal equation, and because it's got these other letters, that's all it means. So follow the same process of solving. What would we do first? Well, we want the x by itself. We're going to solve for x
Plus B.
plus the b. Alright,
Yes.
so if we do that, x cubed b plus c, or c plus b, just write it in alphabetical order.
Divide by A.
Divide by a,
And then you're going to have to do like
Cube root.
where.
going to have to cube root, yep. So cube root,
And that's just going to be the answer. Right?
and that's going to be the answer. Now, there is an alternative way that you could write that.
Does it matter?
Does it matter? I don't think that it matters, no. Unless you're asked to write it in a particular way. However, for if there was a multiple choice question, the multiple choice question
Oh, yeah.
could be written in either of those ways, and so you just need to recognise that they mean the same thing.
Are these type of questions likely to be in the non-calculator exam, would you say?
Possibly, could be in the non-calculator. All
That
right,
exam is
one more of these literal equations, because I just want to point something out. Right, so C. All right, so again, a literal equation. Just because C, so we need
okay, you're going to what plus the C on
got a plus for C, yep. X to the 4 equals C plus D.
and then it's going to be the
Fourth root, yep. Now, there is something else for even roots that you need to keep in mind. Anyone tell me what that is?
You can't like cube or that root negative.
Yeah, it can't be a negative, correct.
Is it like, can you like
What about,
divide it by 2 or something?
what about the number 16?
That's a good number.
It's 4 squared. It's also 2 to the 4.
Yeah.
But it's also negative 2 to the 4. And it's also negative 4 squared. So for any even powers,
It's going to be plus minus.
you've got to have plus or minus in there. The odd powers, you don't have to worry about that. That takes care of itself. But the even powers, always got to be plus or minus when you do the root. All right. So I've got a little note that I'll write about that. So note. Even powers. So b to the n equals a. B would be plus or minus. The nth root of a. But for odd powers, b to the m, for example, if that is odd, we only just need to write it like that. That's not very good, is it? Rewrite that. And that will then take care of itself. So an example might be, so the cubed root of 8, for example, is 2. All right, because 2 times 2 times 2 gives us positive 8, but then the cubed root of negative 8 is negative 2, because negative 2 times negative 2 times negative 2 gives us the negative 8. So there is, in the case of the odd powers, only just one possible solution.
So if you were going to write it in the fraction integer form, would you still have the plus minus that front of the bracket?
If you were to put it in index form, yeah, you would. All right. One more example. So that's the literal equation stuff. Let's look at simultaneous equations. Done lots of simultaneous equations. So this is just a reminder. I do, it's terrible, isn't
It's
it?
kind of smudging it around the lamp.
Didn't someone else bring up this conversation?
I was thinking that we got over this last week.
All right, so example.
How did you think that through?
All right, so we've got a circle and a straight line, and we're asked to find the points of intersection. So if we've got a circle, there's a few different options. With the line could not go through the circle, it could touch the circle, or it could cut through the circle. There's three possibilities. The way this question's worded, it's kind of indicating that this is what we've got. So simultaneous equations, elimination's not going to work very well with what we've got, so we're going to have to resort to substitution. So if x minus y equals 0, we then add y to both sides, we get that x equals y, and so then we would substitute that in. So if x equals y, what I'm going to do is substitute that in up here. So I'll substitute the y up in there for the x. Alright, so substituting. And then I get y minus 4 squared plus y squared equals 16. Alright, any suggestions? No suggestion?
Bracket.
Expand the brackets, yep. And when you do that, you get y squared minus 8y plus 16 plus another y squared. And that equals 16. So when we collect some like terms, we'll get 2y squared minus 8y. And then we've got plus 16 equals 16. So when we neaten that up, we would get
Equals 0.
take 16 from both sides, yeah? Oh, this is an easy one.
Right down, you've written away.
Now what do you notice?
It's got a square thing.
Got a square thing? Yep. What else?
It's got a 2.
It's got a 2. So
Oh,
it's a common factor.
Why?
2y. What's going to be in the bracket?
Y.
K.
4.
4. All right, so our two options for y are 2y could be 0, in which case y would be 0, or y minus 4 could be 0, which means y would be 4.
Mr. Simmons,
Yes?
could you, like with the first step, could you just square
Yeah.
both sides as well? And then do it that way?
Would you...
Square both square, like take the square root of both sides.
All right, problem is plus.
So you don't know
Because
what
there's
the
a
plus
plus,
are.
you can't just square root both sides and get rid of the squares. because of that, because of the plus. So yes, you have to expand it. All right, so we've got to, and what we also know from this one here is that x is equal to y. So we know x is equal to y, so the x value for this one here would be 0, and this one here would be 4, so our 2 points of intersection are 0, 0, and 4, 4. All right, that is it. So that's exercise 4H. All right, now there's maybe some of these equations that you'll do using your calculator, but do it by hand. That's how we need to do it by hand. And as far as the plan is concerned,